Have you ever wondered how to convert an array into a 2D array with conditions using Python? Today, we're tackling this fascinating problem. Picture this. You're given an integer array and your task is to craft it into a 2D array following two rules. Each row must contain unique integers, and the 2D array should have the fewest possible number of rows. Sounds intriguing, right? So, how do we accomplish this? Let's delve into the Python code to solve this intriguing problem. First, we handle a special case, when all elements in our array are unique. This is a rare but critical occurrence to account for. So, how do we check for this? We use the set function to remove any duplicate elements from the array. If the length of our array remains unchanged, then we know that all elements were indeed unique. We can check this using an if condition. Python's ln function measures the length of the array, and the set function removes duplicates. If the lengths of the original array and the set are equal, it means that every element in the array is unique. In this case, we can simply return a 2D array with a single row containing all elements. This is done by enclosing our array, nums, in another set of square brackets. This is how we handle the special case. Now let's tackle the general scenario. For the general case, we first need to count the frequencies of each element. In Python, we can accomplish this by creating a dictionary. Each key in this dictionary represents a unique element from our array, and the corresponding value is the frequency of that element. We use the built-in counter function from the collections module to generate this dictionary. Here's how it works. We pass our array as an argument to the counter function. The function then iterates over the array, keeping a tally of each element's occurrence. The result is a dictionary where the keys are the unique elements from our array and the values are their respective counts. We assign this dictionary to a variable. Let's call it x. Now, x holds a record of each element's frequency in our array. It serves as a useful guide as we build our 2D array. With the frequencies noted, we're ready to create our 2D array. Now comes the exciting part, creating our 2D array. To begin with, we initialize an empty list which we'll call z. This list will store the rows of the 2D array we're about to create. Then we extract keys, which are our elements, and values, which are the frequencies, from the dictionary into separate lists. We'll call these lists x1 and x2 respectively. Now on to the main event. We start creating rows until all elements are used up. This is done using a while loop that continues as long as the sum of all frequencies in x2 is greater than 0. In each iteration of this loop, we create a fresh row. Let's call this we. Now, we need to fill up this row. To do so, we iterate through our elements and their frequencies. This is done using a for loop, where I is the index of the current element and its frequency. Here's the trick. If the frequency of an element is 0, we skip it. It's already used up. But if it's not 0, we append the element to our current row y and decrement its frequency in x2. This ensures that each row will contain unique elements only. Once we've gone through all elements, we append the completed row y to our 2D array z. We continue this process until all our elements are used up. And just like that, we've constructed our 2D array. Scene script. Let's wrap up what we've covered. We began by introducing the problem statement and then moved on to handling the special case where all elements in the array are unique. In this case, we simply return a 2D array with a single row containing all elements. Next, we delved into counting the frequency of each element in the array using a Python dictionary. This helps us understand how many rows we might need in our 2D array. Then, we got our hands dirty by initializing an empty list to store the rows of the 2D array. We divided our dictionary into separate lists for keys and values, and then we started populating the rows. We meticulously created rows until all elements from our original array were used, ensuring each row consisted of unique integers. Finally, we returned the constructed 2D array. And there you have it, a comprehensive guide to converting an array into a 2D array with conditions using Python. Happy coding!